Yeah, hi everyone. Welcome to Data Visualization 2, Part 2. So, in this class, we'll look at this is our agenda. We will see, can I zoom it? I don't think I can. Okay, so we'll look at so in the previous class, we looked at single variable, right? Univariate analysis, which is basically we took a single uh, we were plotting graphs using a single feature in the table. So we have a table and then we just used one particular column to plot the graph. So in this class, what we'll be doing is we'll use two of them. So this is bivariate. So we'll use two features to visualize the data. Essentially, when you have two features, immediately what you will think about is comparing them, right? So something like comparison or something like that. So we'll be using line plot using two features, then scatter plot as well. I think we didn't discuss this in the previous one. Then these two are primarily numerical and numerical. Both features are numerical. Then we'll look at both categorical features, how to plot the how to plot the chart. So rather how to make a plot. We'll be using dodged count plot and stacked count plot for categorical and categorical features, and then for numerical and categorical feature we'll use box plot and bar plot. Then we'll look at something called subplots. Basically, subplots is nothing but how do I, so if we have a single figure, how do we accommodate like multiple plots in a single figure? Just to get a high level overview. So that's what we'll be discussing in this class. So let's begin with the first topic. So we'll be doing the line plot, and let's do the usual ceremony. Pip install numpy pandas, then matplotlib, then cbon. Obviously I have all this. Then I'll just import them. Import numpy as np. Import pandas as pd. Import matplotlib dot pyplot. So if you remember, we are only using the submodule to do the plottings. Give the alias as plt and then cbon as sns. I have my imports. Now we will be operating on something called game data. This is a new data set. I don't know if I used this in the previous class, but anyway, we'll be using this one. So df equal to pd dot, I'll read the data set csv game data dot csv. Let's look at the data ones. So this is our data. It's basically, yeah, I think we did use this data set in the previous class. Basically list of games and their sales in different regions, which is North America, Europe, Japan and other sales, and this is the total global sales, which is the sum of all these. These are different types of games, and if we look at the genres of these games, let me see, the genre is genre dot value count. So these are all the type of games that are present in this data set. Now we are doing a bivariate analysis. And we are doing on numerical and numerical. We are using two numerical fields. So let's look at the first question. What is it asking? Plot the sales trend over the years for the longest running game. Sales trend over the years for the longest running game. So if we want to find, so we have the year data, right? So if you want to find the longest running game, so which is this, the name column, we'll have to find the minimum year and the maximum year for this one, for each of these games. So we'll have to do a group by on the game name, and we'll do an aggregation on the year column, right? Let us do that. Let's check that once. So it's called GDF. The group data frame is df group by group by. I want to group by the name of the game, and I will perform an aggregation. Let's check what this is giving. And groups. Okay. Let's remove this GDF. So there are about 11,000 of them, 11,500 approx, and you see here there are. You see for each game, okay, there is one index here, but you see some of them have two indices. Some of them have three indices. So for those which have only one index, which means there's only one value in that field, which means the min and max will be the same for that, right? For those which have two or more, there we might find different years. So you see there is FIFA has 3 indices. Again, another FIFA has 4 indices. So we'll proceed on this one. We'll perform an aggregation, and we can do this multiple ways. Let's do it the standard way, which is rather actually I don't remember the other way. I think the other way would be something like I have to pass a dictionary of key would be I want to perform the aggregation on the year, and the aggregation would be my min or max. And then I think I should pass another. If I let's just visualize this one. So I have my max year. This is the max year of all this. And if I do a min, this is the minimum year. I think I have to give it this way. 1 second. I pass another dictionary key, and value would be min. No. Okay, I guess, or maybe I just have to pass it here itself, since it is a dictionary. No. Okay. So there is another way, which is what I remember. We can specify the column name as well. So we'll say max year would be we'll pass the column name, which is year, and the aggregation, which is max, and then we'll create another column called min year and min. So if we do this, now you will see we have our min and max. Since we have both min and max, what we can do is we can, let's call it group data frame. We can create a range, which is basically our max minus min. GDF max minus GDF min year, and if we then visualize the thing, we have our range as well. So here if you see, we see all zeros here, so that means we just saw in the and in the groups list, right? So some of them have only one value, so for them the min and max will be the same. So 2006 minus 2006, obviously 0. So what we'll do is we'll sort it in descending order, so that descending order of the range, so that we'll see the actual value. So GDF dot sort values, and I will sort them on the range, and then we will give it as ascending false. So now if you see, we have our sorted data frame, and as you can see, there is ice hockey, which has the highest is basically the what's that? Yeah, the longest running game, followed by baseball, followed by Battlezone. So all of this. So we, as per the question, plot the sales trend over the years for the longest running game. So now we know the longest running game. So let's get the data for the longest running game, which is ice hockey. So we will go to our original data frame, and we will filter we'll do a df.lock, filter all the names which has ice hockey, all the records, all the ice hockey records we are filtering. So let's call this ice hockey, which is okay, let's be more explicit, ice hockey. Yeah, that's fine. CKY ice hockey. Now if we see our data, we have all the ice hockey data. Now the question is, plot the sales trend over the years for the longest running game over the years. So we'll be doing a line plot basically. So simply we do SNS dot line plot. Let's look at the documentation one. So obviously it takes in the data frame for the data, which is our ice hockey, and it takes x and y values, which is if you see the parameters, the arguments, it says variables that specify positions on the x and y axis. So we can either, so if we don't specify the, so suppose let me just or multiple y values, show different subsets of data. So this is basically vectors or keys in the data. So vectors means we can either provide the entire series directly, or we can just provide the key. So let me just show you what this is saying is. So on the x-axis, so on the x-axis, we will take, what is the question? Sales trend over the years for the longest running game. So on the x-axis, we'll take the years, and on the y-axis, the sales, global sales. We'll take global sales because there's no mention of any particular region, right? So okay, I'm sorry, I was not showing. So on the x-axis we'll take years, and on the y-axis we'll take global sales. Let's do a, this thing is too long. Okay, so on the x-axis we will take the year, and on the y-axis we will take global sales. Now if you see, this is our plot, right? Obviously we can do all the usual x label, y label, and then plt.show, all of that we can do. The other way that we can do is, it x and y values take either a vector or the keys, right? So right now this is the key value. We are passing the keys. If I don't pass the data here, I can directly do something like I can pass the series directly, because these are the vector values, right? This will also give us the same result. So so that is the so that's how you do the plotting. Now what can we infer from this one? So it looks like the highest ice hockey was most popular from around 1986-7ish to 1990 approx, or rather it peaked in this year somewhere around 86 to 89, I guess 86 to 88, 86, 80, 87, 88, around these 3 years it saw the it was most popular. Let's see, what's the question? Sales trend over the longest, over the years. So that's the yeah, so that's the thing, and it has remained flat, you can say, over the years. The line is too flat actually, so this could be something. So, and by the way, these are in millions. The global sales are in millions. So after 1989, the sales remained flat. This is in fact too flat, which I'm not sure. We'll see what the cause could be. 1 second, ice hockey. Let's take year. Ice hockey, ice HFCKY, year greater than, say, 2000. Yes, so I guess 0.47. I think this was imputed data. I think they missed the data for these years. So that's why. So the data is not quite accurate, but the plotting is correct anyway. So we see here the data is constant here, which is why we see a constant line. Yeah, so that's one way we can read the data. So you can see the in 1987 approx, it got the highest sales as per this data set, which is around 16 million. And since 1990, the sales remained flat at about we can see the data here, 0.5 million. So that's how you plot this. Let's go to the next question. Find the sales trend in North America of the same across the years. So North America. So instead of global sales, now we want to find the sales across North America. So we'll do an NA sales here instead of global sales. So this is the North American sales figure, or rather sales chart. So if we see here, this thing has again in North America the sales peaked at around 2003 at about 1 million. close to $1 million, and steadily it was declining. Again, this could be the dataset issue, right? It started climbing, you can say, at on 87. We saw in the previous dataset as well. However, in North America, the trend seems to have, or rather, it seems to have lasted longer compared to globally. In North America, this seems to have lasted longer. The popularity was it seems to have been more popular in North America for a longer period of time compared to the rest of the world. What else can we see here? I think yeah, there was a peak in 1980, I guess 3 or 4 somewhere, and then there was a sudden decline for some reason, and then it just went up. So yeah, that's how you plot this one. Now let's look at the next question. Limit the plot to only the last decade of 20th century. So last decade of 20th century. 20th century is basically 2000, right? So last decade of 20th is 1990 to 2000. Which is 20th century is basically 1900 to 2000. So yeah, so what we can do here is we can do the same, and we can do a plt.x limit. There's a method called x limit. Let's look at the documentation once. So set the x limits of the current axis. So we can restrict this one. The what it takes are it takes a left and a right for x limit. So we can set something like this. So the left would be the last decade, right? So left is basically 1990, and right would be 2000. Yeah, that is it. So as you can see, the range is from 1990 to 2000 on the x-axis. So that's how you set that. And then let's look at the next question. Compare the same sales trend between two games, ice hockey and baseball. So we want to compare multiple games in the same style. So what we have to do is we can just get the data of ice hockey and get the data of baseball, and then plot both of them one after the other. That will merge both the things automatically. So we already have ice hockey. Let's create the baseball data, which is excuse me, baseball. Is it exactly baseball? I think it is. Right. So if I do an iLock, or rather lock on baseball, I have my baseball data here. So that's my baseball data. 3. Let me just see shorter table. Now all I have to do is do the same. Instead of ice hockey, I will set it as baseball. But I don't think it's asking for North America, so we'll just set it for global sales. Right, so now if you see, it's comparing both of them. Now, how do we know which is what? So for that, we have to give the label. Let me just check the documentation once. So we have data XY, we have hue, which is basically we can set the color thing, and marker, style order, estimator, sort error style. There is legend, but we don't give legend because legend is there is some issue with legend, so we won't be touching legend. We will directly give the labels. Wait, am I missing the labels for some reason? Let me just check it here. Weights, hue, sizes, dashes, markers. Hue, size, style. Strange. Was it labeled? 1 second. Label as okay, and yeah, okay. So for some reason it's not visible here, which is strange, but yeah, so you can give the label that way. Auto, brief, full, false. How to draw the legend if brief, numeric, hue. Okay, that is strange. Yeah, it's not there in the documentation, but you can give labels. We can try one more thing. If we set the legend to auto, if the legend is auto, I don't know, since there is a default, I don't think it will, but anyway. So that's basically how you identify both the trends, or rather both the lines, both the plots. So if we see here, baseball has almost a steady increase in popularity, while globally, while ice hockey, as per this data set, there was a huge spike around these 3-year period, like 1987 to 89, and then it declined and it became flat again as per this data set. So yeah, that's how you plot this. Am I forgetting something? I don't think so. I think yeah, that's it. Now let's look at the scatter plot. Let's look at the next question. Find the relation between rank and global sales of all games. So this is for checking relationship. Of course, this is also in one sense checking relationship, but the difference between line plot and scatter plot is if you have, like in scatter plot, you can check a lot of data points, like a huge number of data points. You can compare them. You can actually get the info easily, but if you use any other chart for this, it won't be that clear. So that's the reason why we'll use scatter plot. You will see here the thing anyway. So find the relation between rank and global sales. pretty straightforward. So we'll do an SNS dot scatter plot. If you look at the documentation, the great thing about Seaborn is it has a very consistent naming convention, like arguments and everything. So you can just you don't have to think about these things much. So the data is the same. We'll use the which data we'll use? Find the relationship between rank and global sales. Yeah, we'll use the original of all games. Yeah, of all games. So we'll use the original data frame here, and the X key will be rank, right, between rank and global sales. So rank will plot it on x-axis and global sales on the y-axis. Rank and what is the exact thing? Global sales. Rank is rank, yeah. So if you see this one, as you can see, for all the games, and we saw in the beginning, right? So if we look at the games, how many games are there? Name dot count. So there are 16,000 games. So imagine, like, which we cannot use a bar plot for this because that will be too illegible. Line plot, I mean, this will be completely messed up, right? So we cannot. You will see like innumerable spikes or whatever it is in here. Line plot is anyway not the correct fit for this. We can actually test it right here, line plot. You see here, it's taking a lot of time. It's actually struggling. So you see here, this does not make any sense. So line plot is out of question. Bar plot, or rather count plot, is also out of question. Cannot pass both. Yeah, okay. So for count plot, we do not use this one. Okay, let me not confuse you too much. We'll come to count plot in two variables. We have to pass hue instead of y. Anyway, that's the advantage of scatter plot. You see here there's a plotting, or rather checking, comparing a lot of data points. Scatter plot is really useful. So that's how you do it. Then the next, or rather, yeah, we'll do the next question and then we'll do the analysis, or we'll find the insights, because both are kind of related. So are rank and sales positively or negatively correlated? So if you see here, this is the sales and this is the rank, right? So as rank increases, so if you see here, 15,000 rank has the least amount of sales, and if you see the slope, the kind of the way the graph is curving, or rather dropping down, there seems to be a negative correlation, right? As the rank increases, the sales seems to be decreasing, right? So if you see here, at the rank 1, let's suppose here rank is 1, the top ranks are consistently, the sales are above 10 million, nothing below that, reaching up to 30 million, 30 and above. And as the rank increases, we see here for rank, let's say 2,500, the sales seems to be dropping. We are at about 7-ish or something. Then at 5,000 we are at close to 6 million, and at 7,500 we are at 5 million. At 10,000 rank we have come to 3 million, right? And at 15,000 the rank, as the rank is increasing, we are seeing a steady decrease in the sales. So it's a negative correlation. Now how do we make it clear? So to make it clear, there is a plot called regression plot. So we do SNS dot reg plot. If I'm not wrong, I think that's the title. And again, the same set of arguments, the same parameters. If we do this, Is it not rig plot SNS dot linear regression model fit? Okay. I think I'll have to pass something here. I have to say, yeah. 1 minute. We have to do estimator none, scatter. Yeah, we'll have to set these scatter to false. We don't want the same thing, CATT here. We don't want it to do a scatter plot and then slowness log x partial. Yeah, we can set a color as well. I don't know what's the default color. Let's check the default color. The default color is a blue line. Doesn't make much sense. Rather, it's not very clear. So we'll pass color. If I'm not wrong, the colors are I think if it's R, it is red. I think it is. If it is a K, it's a black. This is something you don't have to remember. We just have to check the, like, we can just Google this stuff. I mean, it's not so important. So anyway, so we'll have to pass the scatter as false and color to red. So just for making it more legible. So you can see there's a downward trend. So this that makes it kind of clear that there is a negative correlation between rank and global sales. Yeah, so if we have to do more analysis, like there are some outliers here, even though the rank is lower, they don't have much sales. These obviously outliers can be ignored, but the large chunk of data, if you see here, in fact the outliers are countable, even though the data set is like 16,500, so countable on fingers, like it's barely like about 10-20 of them that are outliers. So the large majority, as you can see, at the highest ranks the sales are maximum. At let's say at 0 to, I don't know, maybe like about 1,000. If we take top 1,000 ranks, it has the maximum sales starting in the range of 10 million to 30 million, right? And you can say the next set of sales from 1,000 to maybe 5,000. The sales range is from say 5 million, about here, right? So 5,000 rank, say about 5 million or maybe 5 to 6 million, 5 to 6 to 7 million to at 1,000 rank around 15 million. That's the next chunk, and then the rest of the things are in the other chunk. So that's basically scatter plot. That's basically numerical to numerical feature comparison or feature plotting. Let's look at categorical and categorical. We'll be looking at dodged count plot. So dodged count plot, basically it looks something like this. You are trying to compare categories within a category. So it looks something like, right? So you will have like maybe you will have the company name versus the type of games they have released, rather the genres, right? Maybe like we want to plot say company X, Y and Z. Company X produced action or maybe sports or some other one. So we want to compare company wise. You want to compare the genre and the company, and in each company, or rather, how do I put it? Yeah, category inside another category. Again, it's not something. Uh, um, no need to think too much about it. So, like I said, if you have, um, let's say you want to know which companies are investing in what type of genres. So in that case, we can use something like this one. Again, we'll look at the question. I think that will be clearer. So find games that are top 3 in genres and publisher and platform. So it wants the top 3 in all these 3 categories. So look at our data frame. So top 3. So DF, let's call it top 3 genres, then top 3 publishers, and top 3 platforms. So top 3 would be DF genre, there is genre. And to get the top 3, what we will do is we'll do a value count. So if we do a value count, what does it give? So it gives us right in it gives us the data. It gives us the count of each category, or rather each value in how many occurrences of each value are there in that column, and it automatically sorts them in descending order, right, from high to low. So we already have this sorted. So all we have to do is we have the index, so we do an index. So if we take the index, that these are our indices, so we want the top 3. Anyway, these are top 3, so we will slice it from 0 to 3, right? 0 to 3, 1 to 3. So these are our 3 things. So we'll do the same. We'll use the same procedure in all 3 scenarios, or for all 3 categories. Just the publisher and what is the other one? Platform. So we have the data for all 3. Now the question is find games that are top 3 in all these. So we have to use the EASIN. If you remember, if you watched the Pandas series, we'll be using the EASIN function. So let's say df, I want to find all the genres that are present in top 3. This will give us a Boolean mask, right? The same thing we will do with now. Okay, before that, let's just get this. We'll do a lock. Lock is quicker, so we'll use the same thing. And so we got our list of genres that are in top 3. Let's see, where are the genres? So you see here, most of them are did we get top 3? 1 second. Action, sports, yeah, we did action, sports, and miscellaneous. Yes, that's correct. So if we just to verify, we'll do a unique. Yep. So we do have the correct number of we do have the correct records. So we want for all 3. So all so what we have to do is we have to Um, again, we'll do an easen for all those three categories, and so we'll do an AND here. So we'll use the same functionality. Publisher and platform. So top 3 pubs and the top 3 platforms. So if we check this, this will give us all the, so basically these are the top 3 in all these 3 categories. Now these are basically the games that are top 3 in all these categories. If we look at the name, do a count, there are about 617 of them, right? Let's call it top 3. Top 3 dot head. These are our top 3 now. Yeah, so these are our top 3. What's the question? Find games that are in top 3. Yep, so it's not asking us to plot anything, so that's the top 3 games. And now how can we compare the top 3 platforms the above publishers use? Excuse me. So how can we compare the top 3 platforms? The above publishers use. So when it's saying above publishers, it's asking for publishers in this data set. So the thing is, we use the dodged count plot. Again, as the name suggests, it's count plot, so we use the same method, count plot. Let's look at the documentation. XY order, hue, orient, color. Don't think we have to set the hue here. Count plot, how can we compare? Dodge. I think dodge should be true, is it? When hue mapping is used, other elements should be narrowed and shifted along the orient axis to eliminate overlap. Set to true. Okay, maybe. Again, the data, obviously the data will be top 3. How can we compare the top 3 platforms the above publishers use? One second, let's just set it to platform. So platform publishers. X would be publishers. We'll set X as publishers, and I don't think we should set Y. One second. Y is platform. Dodge. DODGE. No, is it hue then? It is, okay. It is hue. What if I remove the dodge? Okay, so it's just hue, fine. So as you can see, that is how we get the dodged plot. So you can see here we are already getting the legend here because we set the hue as platform. So if you see here, how do we, or rather what can we infer from this chart? We can see that EA Games, like EA Electronic Arts, has disproportionate spending on in PS2 games, right? Rather it invested a lot in PS2 and PS3 more than the other two publishers, and while Namco Bandai seems to have invested heavily in desktop, and Activision seems to be very like consistent in in all three platforms. It has like almost similar interest in all three platforms compared to the other two. So yeah, that's how you can get some data. Yeah, and by the way, count, right? So count is it's the count of the occurrences in in those fields. This is not sales or anything. This is categorical and categorical. So it found that Activision and Activision and PS3, these many occurrences were there in that in that table, and same with it's the occurrences of both the categories. So that is how we do that. Now let's go to the next question, which is stacked count plot. How can we visualize the distribution of genre for top 3 publishers? So again, top 3 publishers, we'll use the same data set. Distribution of genres. Yeah, we'll do the same but for stacked count plot, we won't use the count plot. We'll have to use something called a contingency table or a cross tabulation table. This is something you will see in pandas. So we do something like pd.crosstab, and we want to visualize, if you look at the documentation, okay, 1 second. Okay, so if we look at the documentation here, crosstab takes an index and columns. Index is basically array like series or list, values to group by in the rows, and columns array like series list, same, values to group by in the columns. So so this doesn't take a data or anything, so we'll have to pass the columns, rather the series directly. We'll pass the series directly. So what this does is pretty similar to what we saw above, which is basically it is checking both the categories. So if you see in count plot, it is checking the publisher and the platform together, how many times these both together occurred, and then it's plotting it, right? So crosstab does something similar. What it does is, oh wait, what are the things? Index. So we'll pass the index as anything. I mean, we don't have to be particular about this. We can pass top 3 genre and publisher. So we'll pass the GENRE and the columns as publishers. Top 3. What's the name? Publisher. Okay. So if you check this one, you see here. Okay, let's switch the names. It's taking too much space. Okay, now it's kind of compact. So you see here, it's Activision and Action. These two categories appeared in the table 102 times. Again, EA and Action appeared 59 times, Namco and Action appeared 100 times. Same with these two categories, Miscellaneous and Activision occurred 47, Sports and Activision occurred 45 times. So that's basically what cross tabulation does. This is the data look of this chart right here. So this chart is also doing the same and plotting it. Now what we will do, we will call it cross T. We'll just give it a name, cross T, and we will use a inbuilt pandas inbuilt plotting function, which is basically pandas has a inbuilt matplotlib. It actually uses matplotlib underneath. So this so right now, if we look at the type, what is the type of this? It is basically a data frame, right? So we will use this. There is something called plot, if I'm not wrong. Yeah. So there is a plot method on this data frame itself, and let's see. What does it take? Parameters, data, obviously. The data we already have, and then X label or position, Y label, position, or list of labels, positions. I think right, so kind, we have to pass the kind we have to set it as bar, because this is like a bar plot. So if I show, let me show you how it looks. It looks something like this. So stack is basically stacking one after the other, right? So we will have like it will represent a portion of this stack as one of the categories. So maybe stacked something like this and something like this. So this could be the company name. This could be the other category, which is what is it? Genre. In this case, it could be action. It could be, so like the advantage of stacked bar chart is we can look at the totals of a company. Like it's again, all of these are meant for visually quickly getting insights on about the data in a visual format. Like so if you see here, we'll call it bar and the axis subplots. Fixed size, use index, title, grid. Let me see. I think this should be, that is sufficient. Okay. I think there is one more. if I'm not wrong, has kind hist. Okay, title. I guess it's the title. Is it title? Plot. So X label. Okay, we can give X label and Y label as well. So let's give X as publishers and Y is our what is Y here? Y is the count. It's the frequency. No. We have list like key, checking, indexing error, key error, publishers. One second, I think column 1. Oh, okay. It's publisher. We have list like key, checking, indexing error, key error, publisher, PUBLI. Is it not correct? Label or position default none. Maybe we don't give. Why is it? No. Allows plotting of one column versus another, only used if data is data frame. Okay, anyway, I don't exactly remember what else is necessary, but anyway, this is basically our. Oh no, this is not. This is right now. This is, if you see, this is actually dodged bar chart. This is not stacked. I think kind and I think I have to give something else. 1 second. X level or position, so Y level. Layout fix. Yes, so this is the other argument, which is stacked true. This is stacked bar chart, right? So, and there you go. That is how we see we get the stacked bar plot. So you see here, this is like far, like this chart kind of makes it clear that EA invests heavily in sports, right? If you see the large bar, it's visually clear that EA is more into sports than any other genre. If you see, the Activision is heavily invested in action, and Namco Bandai similarly is also invested in action. So that's the thing. It's visually clear what each publisher is interested in. So that's about this question. Now let's look at, where are we? Stacked. So now let's look at numerical and categorical analysis. We'll look at box plot. We already saw the basics of box plot before. Let's look into this question. What is the distribution of sales for the top 3 publishers? Okay, so we are looking at bivariate, numerical and categorical. So distribution of sales for the top 3 publishers. So Okay, pretty straightforward. Box plot. We'll just do a box plot. The signature is the same, right? We will use our data. The data we will use for top 3, which is the one we made before, which is this one, top 3 dot this data. So the data is top 3 and X is distribution of sales. So X is our publishers, right? We'll set publishers on the X-axis, and sales, it did not mention any particular region, so we'll use global sales. And we look at the data. So as you can see here, there are some outliers in Namco Bandai, right? There are some super hits in EA as well, but we don't see any outliers in Activision. That's the first thing, right? And the maximum sales for Namco Bandai seems to be around 12 million-ish, and for Activision, max sales went up to around 17 million, and for EA it went up to like 18, about 18 or something like that, right? There are outliers with 21 as well. So that's kind of interesting. And if you look at the IQR, the range is for Namco Bandai, it's from around 4 to 7.5. For Activision, it's 7.5 to 12.5, and for EA, it's around 9 to 12.5. The median for Namco seems to be at around 5. For Activision, it's around 11, and for EA, around 12 million. So that's how you can look at the data. So if you see here, the thing is a lot of Namco Bandai games, Bandai's games fall above the 50%. One second, let me run this again. So a lot of Namco Bandai games seems to be in the greater than 50% range, right? So it has lot of exceptionally good games, in one sense you can say, or rather whatever it did, it seems to have exceeded its general expectations a lot of time. So because if you the 50th to 75th percentile, these are like the exceptionally good ones, right? From there and above. So Namco seems to have consistently exceeded its expectations. Activision has a fairly balanced this one. So if it released 10 games, 5 of them are have underperformed, 5 of them kind of overperformed, and EA seems to have the median. It seems to have again, if you look at the box and the whiskers, it has a longer it has long whiskers, and again, it's not necessarily a bad thing that its median is like slightly above. It probably tried a lot of games, and a lot of its games seems to have fallen under the 50% range, and few of them seems to have exceeded. But then again, it's just like the movie ratings. If you see, if you just have few ratings, and if many of them gave like higher ratings, you will have like a like a greater rating. But if over a period of time, as lot of people rate the movie, you will see that it will somehow fall under you will see the real rating when a lot of people, when the sample size is larger. So here I think EA just has a lot of games, so probably um, that's why we see that. I probably maybe experimented a lot more as well, who knows. But anyway, this is as per the data set, so I don't think any of this data is real. So anyway, that's how you can read this data. Let's look at the next question. Now, how to visualize which genres bring higher average global sales? So, okay. So this is a classic categorical and numerical data, right? So we can use bar plot, and we'll use the same count plot, which is SNS dot count plot, and we'll pass the data as genres which bring the highest global. So we'll pass the original data. We won't use the top 3 here. This is the original data. X, we will set the X as genres, which is GENRE, and the hue. If you remember, count plot does not take X and Y, it takes the hue. The hue here will be our global sales, global underscore sales. Oh, did it disconnect or? Oh, it's taking longer. I think there are too many. No, I don't think so. There are not that many. Let's use top 3. I think this is. Genres which bring higher average global sales. 1 second. I think we have to set something here. Excuse me. Genres which bring higher average global sales. Higher average. So you see here, it's asking for average global sales. So average for every genre. So what we have to do is we have to give the there should be a way to set mean somewhere. Interesting. I think hue order, orient color. Formatter. Is it a bar? I don't think so. Okay. Okay, we'll use a bar plot here because that will give us the estimator, which is the mean. 1 second, I think it was bar plot. Bar plot. Yeah, the arguments are the same, and we have an estimator here, which is the mean. So, does it have a hue? It has a hue. Okay. STIMATOR estimator will, the default is mean anyway, so we don't have to give it. So if you see here, the default is mean, right? So either that, or I'll just show you estimator. We can do np dot mean. Even without that, it will give us the same because the default is the same. So top 3 genre. 1 second, I think something is wrong here. Genre dot value counts. There are only 3 here. It should give only 3. I'm not sure why it's giving so many action. Setting something wrong. Data top 3. So we have 3 of them. Hue is global sales. It does not matter if we provide this or not, it should be the same, but interesting. Bar plot, genre. So should not happen. 1 second, something is weird. Data is top 3, access genre, use global sales. Wait, how to visualize which genres bring the higher average global sales? Seems to be correct. Okay, this is not count plot per se, so we'll use so this is bar plot, we can use x and y. So that is how we can visualize the global sales of genres, and we are doing an average. So even if we remove the estimator here, it will still give us the same, right? We can do, if we want to set a different estimator, we can do an np dot sum. Like if we want the sum of sales, that will give us a different one. You can do a median if you don't want an exact average, right? So that is that's how we do this. So if we look at the data, what we can infer from this is obviously sports seems to be the highest grossing genre, followed by action and followed by all other genres, right? So that's how we do this one. Next, let's go to the next question. So now we'll be coming into subplots. Subplots basically, like I said in the beginning, subplots is basically you want to see a high level overview of all the charts. So if you look at this one, if I press this Google's option, it will just what it's doing is something like subplots, right? We'll be doing something like this in a single figure. I'll be plotting a bunch of plots, right? We'll have a figure and we'll be allotting a space. So the method we'll use is plt.subplot, and it takes in 3 arguments, which is the first argument is the row, then column and position. So this is the number of rows, number of columns, and the position of each subplot. So if suppose in the figure I give I want 6 subplots, right? Something like I have something like this, and 2 rows. So the way we can do it is I can give 2 rows and 3 columns, right? 2 3s are 6. So I will have 1 2 3 4 5 6. So the positions. So if I say 2 3 1, the subplot will be created here. 2 3 1. This is 2 3 2. Subplot 2 3 2. Here subplot 2 3 3, 2 3 4. 2 3 5 and 2 3 6. So that's the positioning of subplot. So yes, it's pretty straightforward. I'll just use a standard example. Plot the trend of there is a question. Okay, plot the trend of NA and every other region separately in a single figure. Let's look at our data frame. So what's it asking? It's asking plot the trend of NA. So sales trend, right? Sales trend of NA and every other region. So it wants to plot the sales of NA and EU sales, NA and JP sales, NA and other sales, and NA and global sales. So in this case, we'll get a total of 4 subplots, right? Because one is NA and EU, NA and JP, 2, NA and others is 3, and NA and global sales is 4. So we'll do a 2 cross 2 grid, and excuse me. So yeah, so let's proceed with so yeah, again, and by the way, these are numerical and numerical, right? So we'll be using a scatter plot for this one. Since there are a lot of data points, line plot will not make much sense, so we'll use a scatter plot here. Let's see, yeah, we'll set a figure size, so figure, and fig size we can set so the figure size I think I didn't I think I forgot this in the first class, right? So figure size is basically you can set the length and so width and height of the figure. So I will give this as 12 cross maybe about 10, just because there are 4 plots, right? So if we, let's see, if we visualize this, I don't think we'll get anything. Okay, so we'll give it a subtitle, SUPTITLE. We'll call it NA sales versus other region sales. Okay, nothing even now. Okay, so we will do PLT dot subplot. That's the method. And the subplots, like we said, we'll do a 2 cross 2, 2 rows, 2 columns, and the first position. In the first position, we will create a subplot, which is basically we just have to write the plot code in the next line. So SNS dot scatter plot. We need a scatter plot. Again, the data will be df. X is NA, right? We'll take X as NA sales, which will be the constant for all of the plots, and then the Y will be, we'll call it a U sales. Let's visualize this. Positional argument follows keyword argument. One second, let me check. Oh, I think it's here, Y. Anyway, I missed Y here in the scatter plot. But let's just look at the documentation for parameters, args. 3 integers, yeah. This is anyway 3 integers. Let's look at an example here just to be clear. Yeah, PLT dot plot. Oh, we might have to pass an array. One second. Yeah, that also makes sense. Maybe not necessary. Okay. Yeah, so that's the first subplot. We'll give it our title. We'll give the title as NA versus what is this? EU, right? NA versus EU, and NA sales, EU sales. Yeah, we can give X label, Y label as well. Yeah, just to be refresh your memory once. X label, X is NA, and Y label is EU. If you look at that, so here we have NA sales, EU sales. We can call it NA sales and EU sales, but yeah, I mean, you get the idea anyway. Fine, I guess we'll just make it clear. So NA sales, EU sales, what else? Yeah, so we can even set the font size as well. So suppose if my subtitles, we can set, by the way, font size we can set in every single one of the text regions. So if I give 20, just you see here that's a large enough title. So we can set font size in all the text regions. So like if I set title here, I can set a font here, right? So you see that also became big. I can set a font here, a text label as well, right? That became big. So yeah, just to keep the code clean here, I won't do all of that. Now we have the first graph, right? Let's look at our so let's add the next graph. So we'll be making 4 of such plots. So let me just show you how it looks. Okay, so this is the position 2, this is position 3, and this is position 4. There you go. We have 4 plots. Right now we didn't make any changes, so that's how you'll see 4 plots. The other regions, yeah, you know what, I'll just remove these for simplicity, we won't be needing this stuff, that's kind of unnecessary. We'll do NAU, then NA JP sales, then we'll do NA other sales, and then we'll do NA global sales. So that's our, so you see consistently the x-axis is NA, while the y-axis is different. You see global sales, other sales, JP sales. Obviously, we can create different charts. We don't have to do scatter for all of them. If suppose I do a, what is it? If I do a line plot here, yeah. So line takes a little longer. So there you go. So we can create a, different types of plots in each of these subplot grids. Excuse me. So that's how you do it. You can obviously create labels, titles for each of them. You just have to create in the next line. Now the other question is, what if we want to span a plot across full length of the plot? So what it's asking is, it is asking, so suppose if I want to extend this graph to the full width, so right now we have a plot like this, right? What if we want a plot that extends the complete first row, and then we want 2 rows here? Or maybe what if I want a plot that extends like on a full column length, and then I plot something like this, right? So to do that, it's again, there's just something you have to remember. If I want it across the row, then I'll have to remove one of my plots, and then let's see what the result this gives. Okay, let me remove line plot. This is taking too long. Okay, so it's giving us an empty space here. Now to fill that space, all I have to do is set the no, I think I have to set the column to 1. So that will fill that space. Now if I want the column to, if I want this full column length graph, then what I have to do is, excuse me, then what I have to do is I have to get rid of the third or the fourth one. Okay, back to line plot. Okay, so we have 4, right? Now I have to, if I want a full column here, then I have to remove the third one. I'll comment the third one, and the first graph I will extend it vertically. So I'll just have to set the rows to 1. If I set it to 1, there you go. That extends column wise. Obviously, the same you can do in the other column as well, and yeah, you can play around with that. And that's it for this class. I hope that was clear, and yeah, I think there's nothing more left here. Yeah, I'll see you in the next one.